this question, and we found what was the net electric field, the resultant electric field at P, and the position was 0, 10. So now we are going to continue and we'll find what is the net electric field at point Q, and the coordinates are given as, so let's extend this. The coordinate is 20, 0, right? So suppose this is the x-axis, and this is 10, so just let's make it more, extend this more here, x-axis, and suppose here's the point that we are interested in, and the coordinate of this point P is 20, 0, right? So in the question, this point is denoted by Q. So we are interested to find what is net electric field at Q. Earlier we found what is the net electric field at P. Okay, now this is the axial position. So let us just indicate it first. So suppose let E, we have made E1 and E2, let E3 be electric field. So E3 is the electric field at Q due to Q1, and E4 is the electric field at Q due to Q2. Okay, so let's write the equation. So E3. So the magnitude of E3 would be equal to 1 over 4 pi epsilon naught. The value is Q1 is given minus 20, so we are interested in magnitude, so it's 20 over 3 times 10 raised to the power minus 9 Coulomb. This divided by this distance, right? So from here to here. So what's going to be the distance? So let's indicate it nicely. So we know already that the distance is the origin, right? So this is the origin, and from here it is 10 centimeter. From Q1 to the origin is also 10 centimeter. And we now want from Q1 to this value, right? So here, this is 20, right? So 20 means from origin to this place, Q is 20 centimeter. But we are interested from position this, so 20 plus 10, so it's going to be 30 centimeter, right? 30 centimeter would be the distance, which is QA. So this is QA squared, which is 30 centimeter squared is the distance. So this is what we get the magnitude of it, and we know that this is negative, right? So what would be the direction? So this is going to be minus I cap, right? This is going to be minus I cap. So if you want to indicate this is the value, if you want to know the vector, it goes to minus I cap, E3. Why? Because this is negative minus 20 by 3 times 10 raised to the power minus 9 Coulomb. And here at Q, the direction of would be towards minus negative x-axis minus I cap. Okay, now what's going to be E4? So E4 would be, we have E4 is the electric field at Q due to Q2. So the value is plus 20 by 3 times 10 raised to the power minus 9. So it's going to be a repulsive force, and E4 direction would be towards positive x-axis, and it comes out to be, the magnitude is 1 over 4 pi epsilon naught, 20 over 3 times 10 raised to the power minus 9 Coulomb, and the distance, right? So from here, the distance here, right? So from here to here it is 20, here to here it is 10, so 20 minus 10, so this comes out to be again 10 centimeter. So the distance between Q2, the position B and Q is 10 centimeter. So this is 10 centimeter whole square. All right, so let's convert this into, in the equation itself, let us convert this into SI unit. So just multiply by 10 raised to the power minus 2. Here also we multiply 10 raised to the power minus 2. Now we get everything in Newton per Coulomb. That is the SI unit of electric field. Okay, so this is going to be plus I cap. So this entire thing is magnitude. This entire thing is magnitude, and we multiply this magnitude with a unit vector to get a vector. So here it is minus I cap plus I cap. So what's going to be the net value? So therefore EQ, vectorally we need to add it. So EQ is equal to E3 plus E4. E3 plus E4. All right, so this is minus I cap and this is plus I cap, so we need to add it. So this comes out to be therefore EQ is equal to, we take everything common, 1 by 4 pi epsilon naught is common, 20 by 3 times 10 raised to the power minus 9 is common, so 9 times 10 raised to the power minus 9 Coulomb is, this is Newton meter square per Coulomb square. This is common, and this is also common, which is 20 over 3 times 10 raised to the power minus 9. These things are common, Coulomb. And then we are left with this and this. So it is 10 times 10 raised to the power minus 2, which is 10 raised to the power minus 1. Here it is 30, 3 times, so 3 into 10 raised to the power minus 1. So this is going to be 1 over 1 by 10 minus 1 by 3 by 10. Okay, and the resultant is going to be I cap. All right, so this is what we get. Now let's evaluate this. So I'm just using this portion of the blackboard to evaluate the numerical value. So it comes out to be therefore EQ. Let's see the value of it, the magnitude part of it. It comes out to be 9 times 10 raised to the power minus 9, 10 raised to the power 9. So here it is not minus 9, it is 9. 9 times 10 raised to the power 9 times 20 by 3 times 10 raised to the power minus 9 Coulomb into, and this comes out to be squared, right? In this equation it is squared, that is common. So here, so it comes out to be 100. Let's take out 100 common. 100 would be common. There also it's going to be 100 in the numerator. So we take out here again 100. That is 10 raised to the power 2. And we are just left with 9, right? So 9 minus 1, which is going to be 8. So this is what we get Newton per Coulomb as the magnitude. All right, so this comes out to be 8. And this minus 9 and plus 9 gets cancelled. Here it gets cancelled, 3. And we are left with here 5. All right. And also we get here 9 minus 1. And here it comes out to be 9. So 3, 3. So here it's going to be 3, 3. All right. So 8 by 3. So this comes out to be roughly 20 times 8 by 3. Let's write it nicely. So it comes out to be magnitude of EQ is equal to 20 times. Now look here, it's 10 raised to the power 2 and here it is 1. So it's 2, and here it is 8, which is 16 over 3. It could be 16 over 3. So 16 over 3 into, now here it is 10 and here it is 3, so 10 raised to the power 3, and Newton per Coulomb. So if you evaluate this, it comes out to be around 5 3s are 15, 1 3 3 for 5.33. So numerically this comes out to be, I'm writing it straight away, 16 over 3, it comes out to be 5.33 times 10 raised to the power 3 Newton per Coulomb. So we are now able to find what is the net electric field at Q. The position given is 20 10, 20 0, right? So it is on the x-axis, and we are getting this value 5.33 times 10 raised to the power 3 Newton per Coulomb if you evaluate this and calculate this. Take down the steps, it's very important to understand these